Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.
Hello, friends. Yes, hello everyone. You're watching New Generation Airships Project, and we're coming to you live from the AERONOVA company office. As always, I'm Fyodor Konstantinov, and the one and only Gennadiy Babanin. Friends, before we get started, please make sure to leave a reaction or a comment. Let us know that everything is working properly, that you can hear us, and then we can begin. Plus, it helps with promotion. Don't forget to stay active. And if everything's good on your end, can we get started?
Yes, I'm keeping an eye on the vContact stream, so if anything comes up, you can post your questions there.
Yes, today we have a long-awaited topic, how the tests went. And before we dive in, Fyodor, could you share a bit in general? Where did the tests take place? Where were they held? Let's touch on that a little.
Those who have been following us probably already know where we conduct our tests. Actually, well, tests, it's really just the assembly of the airship. The first flight tests. That's right. The first flight tests are scheduled for next week. You might have figured it out from the video. Yes, we're in Novinky. It's an airfield near Serpukhov. It's a large, nice, new, modern, private airfield that plans to become international in the future. We were lucky, really. The airfield's management company invited us, literally saying, "Please, we'd be more than happy to have you." We also got lucky with the space itself. The hangar was provided to us by friends and acquaintances. When they found out what we were working on, they said, of course, absolutely. So we've settled in Novinky. As you probably saw, we really did put it all together. Our last webinar was from there, and you saw a lot of the details and technical specs. Honestly, the week has just flown by.
We assembled it in 1 week.
We literally had just a couple of days to move it out.
Yeah, our senior colleagues are distracting us a bit. They're having a meeting right now.
Well, we'll talk about that later if needed.
We visited the airfield, and being at the airfield is awesome. I just want to say, assembling airships and being a part of something like that, it really hits you afterward, but overall, it's just really cool. And yesterday a delegation came to visit, and they realized that sitting in an office designing things is one thing, but being out in the field, at the airfield where planes are flying, and assembling things, there is something else entirely.
Yeah, seeing firsthand how the project is gradually coming together, that's really valuable.
Being able to get hands-on is important. It's funny, because when we started the project, for example, I personally had absolutely no connection to aeronautics. And a lot of the other project participants also had their own illusions about airships, their own ideas. And it's amusing to watch over time how those illusions get shattered, while the older generation just stands by, smiling calmly, with understanding. Yeah, exactly, like go ahead, go ahead. And honestly, a lot of real revelations happen right there at the airfield during the assembly of the airship. How everything is actually supposed to work, what kind of nuances there are in all of this. Even the most basic thing, for example, an airship filled with gas doesn't try to fall down, it tries to fall up to the ceiling, even though it seems obvious that it floats up. Until you actually deal with it yourself, you don't really get that first-hand experience. But now I have.
Thank you. By the way, an interesting fact, the hangar where the airship was assembled, you could say that thanks to us, we traditionally gave it. How do you say it correctly?
Ealing.
They turned it into an ealing, yes. Because you can call any ealing a hangar, but not every hangar can be called an ealing, since an ealing only gets that status if an airship or a watercraft, something that floats, is assembled and constructed there. Yes, something that floats. Let's talk a bit about the assembly process. How quickly did we put it together? How many days did it take? Well, it turns out it took about a week. We assembled it completely in a week. It was faster than that.
You could even assemble it in a single day. The only thing is, first of all, we weren't in any rush at all. It was literally an order not to rush anywhere, to do everything methodically, to make sure to document everything, to think through every component, every procedure, and of course, to weigh every single nut and bolt. It was very important to see how closely the theoretical weight summary would match the actual results. So, it was basically 3 intense days of work, and we got it assembled, but honestly, in my mind, those days all blended together into a week.
That's exactly right, yeah, because so much happened, and time just seems to move differently there.
Yeah, but despite everything, I absolutely want to say that we did get it out of the hangar, and it flew, but I still want to share a few more especially interesting and noteworthy things about the assembly process itself.
Yeah, did you run into any difficulties? Or maybe some unexpected things happened at the site? Was there anything like that?
Actually, there were almost none. It was all just minor stuff. We prepared well, and we had time to get ready because we were still finalizing that control system. Basically, we did the initial assembly of the gondola right here in the office. That really helped a lot. We also planned out all the cabling here in the office, how it would be laid out, and the second store was just 5 minutes away. So yeah, we were lucky. Everything went pretty smoothly. The issues that came up during assembly, we're actually discussing those this week, reworking some things, making a few modifications, fixing minor mechanical flaws. In reality, for example, here's what actually happened. Ruslan initially didn't want to make many of the parts that connect to the body, because he said we'd do it on the spot. That's something I also raised concerns about. Doing things on the spot means you never know when it'll actually get done. I told him, just make it, set it aside, so I can be sure it's there and will fit onto the airship. And some parts matched up, but some didn't. For example, somewhere the radius is just a little different. With the tail assembly, for instance, you can see in the videos, either the ones that have already been shown or the ones coming up, that the curve of the shell itself is a bit different from the theoretical one we had. The assembly was made according to the theoretical design, and you can notice some slight sagging in the shell, for example. That's exactly what we're discussing here this week.
We're fixing it, and so on. Ruslan probably also had reasons for suggesting we postpone this a bit, so that these issues wouldn't come up. Yeah, we could clearly see the whole process.
Right, but everything has its advantages. First, we assembled it quickly, it came together, and it works. If we tried to make it on site, we'd probably still be messing with it there, but it's no big deal.
Yeah, and with some issues, A regular hardware store wouldn't have been able to help us anyway. But it's good that we didn't end up in that situation. And after these few days, we finally rolled it out of the boathouse. That was a pretty historic and inspiring moment for the whole team.
Yeah, it was cool. Volodya, can you play the footage? You're about to see some unique shots.
Yeah, we even filmed it with a drone. Now you can see how it all happened.
So, this is the first time we rolled it out of the boathouse. It was controlled, of course. David and I were holding the rope. I don't remember the exact technical term for it. We walked behind it, following it across the field. The ropes weren't tight. The airship flew on its own, but just in case of wind or something.
Forsaking.
Yeah, in case it acted up. We were checking for problems. Honestly, I was surprised. Of course, everything is planned, predictable, and so on, but the fact that we would assemble it in such a short time, take it outside, and it would actually fly. On the very first try. Yeah, that's what's so cool about the airship, the fact that it has static lift. The center of this lift is higher than the center of mass. And that's why it's called the roly-poly effect, like those wobble toys. Basically, the airship will always stay with the envelope on top and the gondola on the bottom, no matter what happens. So its static forces keep it balanced. That's why the propellers, the thrust vectoring, the tail thruster, they all affect the flight, sure, but even if you turn all of that off, the airship itself still remains stable and balanced. And thanks to this, and because we have a talented systems engineer who really knows what he's doing, it actually flew on the first try. That was unexpected, really cool, and very satisfying.
And regarding its weight specifications, I wanted to clarify, how closely did it match what was planned? Well, not just planned, but how accurate was it compared to the original expectations?
The second surprise, adding to our list of surprises, was that we hit the mark exactly. The theoretical weight matched the actual weight perfectly. So, after fully assembling the device, we had just a couple of kilograms of buoyancy left. That means that even when the device is fully assembled, it still tends to float up to the ceiling. That's how I'll put it for now.
I remember, we even had to hang an extra bag on it so it would be overweight.
Look, that extra bag is actually the payload. In this setup, it can either serve as ballast or as useful payload, but yes, it definitely needs to be there. Because airships that are too light just don't fly.
But that's not allowed by safety regulations.
Basically, humanity scratched its head and realized that if you let go of an airship and it floats off into the sky, that's probably a bit worse than if you let it descend gently.
If people on board.
And people are on the ground, and most of what they're interested in is usually on the ground too. That's why airships fly with extra weight, and there's actually a margin for this extra weight. So, we would add a 10 kilograms bag there, or you could even add 20 kilograms. And then, here's how it all works. There's a thrust vectoring system. The propellers turn. It uses its engines to push against the air, lifts off smoothly, the thrust vector flips, and the airship starts moving forward. Thanks to its large body and huge surface area, airflow moves around it, like having two giant wings. It flies smoothly, carrying its load with aerodynamics. When it needs to stop, it halts and gently, gradually descends.
Or forcefully with screws.
Yes, you can use the propellers to force it down, especially in cases where there are phenomena called thermals. That's when, for example, a plowed field gives off a lot of heat, causing the air above it to rise strongly. And this rising air, even if the airship is overloaded, will still lift it upward. If you need to land on that field and there's a thermal there, you won't be able to. In that case, reverse the propellers to create extra thrust. The second option is to descend in a spiral, like an airplane, using the tail fins to guide the airship downward and land that way. So, that's how these problems are solved.
It's really great that we managed to calculate everything correctly in terms of weight, because as you said, we even had to add some extra payload, although in reality, that's probably a bit of a useless load. So it turns out we could have attached even more sensors if the need ever came up.
You can hang all sorts of equipment on it. On it specifically, I'm repeating myself for the 100th time, but for those who still haven't gotten it, and there are some people like that, the airship we built is, in fact, actually a scale model of the NOVA-02 airship, and, as you can see, we didn't just build it for fun, we constructed it to fully test the control system. That's what we're working on this week. We're creating it. We're programming the automatic control algorithm for the airship. And the design of this small airship matches the NOVA-02. It has the same number of propellers, the same rotation angles. The thrust of the propeller relative to the drag is also the same. It has the same number of tail fins. The tail rudders have the same turning angles. It also has the same bidirectional tail thruster, with the same thrust relative to the lever arm it's mounted on, and relative to the airship's moment of inertia. And this control system during those approaches. You can't really call them flights yet, they're more like approaches. During those 2 days of approaches that we carried out, we collected data. Right now, this control system is being trained, and starting next week, this system will control the airship automatically. And this is exactly what the NOVA-01 was primarily created for. Secondly, we will try to work out automatic docking at a low mooring point. That's when, basically, in fact, the autopilot will learn to control it. There will be a point on the field. We haven't anchored it there yet. Most likely, we'll do that a week after the flight tests. We'll be working out the algorithms, and also a bit of the mechanics, because it's unlikely everything will work perfectly the first time. But the airship itself, yes, it can carry a payload, just like that. Even if it's just 10 kilograms, NOVA-01 could, for example, carry something like a radar, or a powerful video camera with extra batteries. Even in this configuration, when it's a scaled copy of NOVA-02, we've realized that it can loiter over a specific point, like over a city, for about 10 hours and conduct some kind of monitoring. But this shape still isn't actually optimal, because by copying NOVA-02 and its specifications, we weren't aiming to create the perfect small airship. We were trying to match the characteristics of that airship as closely as possible. That's why we're going to modify it a bit, since there is still, in fact, demand for small advertising and monitoring airships, and those 10 useless kilograms will most likely be put to better use. Into a useful 50, which is already much more interesting indeed.
So, just to clarify, just to be sure, the next NOVA-01 models with the same gas volume will, in fact, look fundamentally different, right?
It's possible the gas volume will increase. 110 cubic meters of helium, total volume 130, or 130 cubic meters of helium, total volume 150. But all of this is still being discussed and is in progress, and for now, the main focus is on conducting the tests. In short, the airship has a goal, and that goal needs to be completed to work out everything for NOVA-02 on NOVA-01, and only then move on to its major upgrade to create a small unmanned version.
And during the flight tests, were there any issues discovered, if any, that need to be redone or fixed, whether they're critically important or not so important? So overall, what are we working on improving right now, besides the control system?
No, there weren't any major issues. It was more about those realizations I mentioned at the very beginning, like when you're running across the field after the airship, especially on the second day when the wind was gusty. Dealing with those gusts. It's generally difficult, yes, for the airship to handle wind gusts, especially when it's very small, and especially when it's close to the ground. After all, the bigger the airship, there's this growth formula for its mass, its inertia, and its resistance, basically, the wetted surface area. So, in general, The larger the airship, the greater its mass inertia and the smaller its wetted surface area, meaning the effect of the wind on the airship decreases as its size increases, especially when it comes to small gusts. And it became absolutely clear, not just in theory, but now, as we can see, it's been realized in practice. For example, right next to the hangar, let's say there's wind blowing up above, but your hangar doors are open and it seems completely calm. You start moving the airship out of the hangar. But then the wind curves around like this, and it starts swirling here, so the farther you move the airship away from the hangar, the less the wind affects it, and the less it gets tossed around, so to speak. If there's a forest behind the hangar, for example, then you need to move it even farther away, ideally about 50 meters. If you're standing on that little patch and there's a forest behind you, it might be calm here, but above the trees, it's not calm at all. The weather up there is completely different. This boundary layer near the ground, the wind layer, is really interesting. And yes, as the airship operators themselves say, an airship has two safe states. The first is when it's in the hangar and stationary, that's the safest. The second is when it's in flight. So, when you rise up above the trees, 30 meters or higher, the wind up there is completely predictable, without those sudden gusts and so on. In general, it's much simpler up there, but things get interesting near the ground.
There are factors that affect it. By the way, you touched a bit on the topic of mooring it to the mast. How did it perform here overall? Did our mooring and mast work well?
There was nothing new here. We just used this mobile mooring mast, set its legs firmly on the ground, and docked to it without any issues. The airship weathercocked around it. There were absolutely no problems here, although, of course, some minor details were discovered during operation. But again, all of this truly happened simply because the older generation sent us out into the field and said, "Go out there and gain some valuable experience." Yeah, but nothing critical, just that now we need to mark which parts of the top and bottom, add height markers for how far the mast extends, and so on. Experience.
When you brought up that topic, I guess you meant the software system, as you mentioned earlier, that will also help it dock properly on its own.
So, look, on the first day, when it was more or less calm, we were almost operating it manually. Well, of course, they told us to stop doing that. We were able to calmly approach that low mast, practically sticking the nose right into it. There was almost no distance left. So, docking to the mast in automatic mode won't be a problem at all. It's going to be very easy and straightforward. Attaching to the lower anchor point will also be completely simple. The only thing is, once again, it all depends on the size of the airships. The smaller the airship, the harder it will be for it to stay at a low mooring point, and that point will be temporary. But with a certain size, it can become permanent. All of this is related to balance, moments, side gusts, and so on. Overall, the automation will be able to handle all of this. After that, it's just the laws of physics, but fortunately, we're moving toward building larger airships, and everything will work precisely there.
Overall, it was also interesting to watch how it weather vanes on this particular mooring mast, catching air currents and wind, and independently choosing the right direction to always face into the wind.
Yeah, it was funny to see how that top weather vane, I can't remember what it's actually called, the central one at the airfield, was pointing one way, while your airship on the ground was facing the other direction. Yeah, I guess the winds are actually different, especially near the ground.
Guests at the airfield yet? Anyone seeing the beauty?
Well, if we're sharing news after the fact, of course we have. You might have seen it in the chats, yeah. Yesterday, we had guests from South Africa visit. They're also at our office now. They came today and looked around. Were they here? Yes, there. Yeah, not only were they here, but colleagues from the same field came too, and people from related companies visited as well. So far, it's mostly just our own people, but with the South African group, it just happened that there was a delegation in the country, so they stopped by too. Overall, I think in about 2 weeks to a month, we'll be able to hold regular events.
Yes, and we're already making plans, friends. We're already planning, so announcements and information will be coming soon. Stay tuned and keep an eye out for updates. Listen, and overall, I think airships are a promising direction for South Africa, as far as I know.
Well, just like in Russia, and in South America too, yes. These are places with vast territories and insufficient infrastructure, where connections between cities and regions are lacking, and so on. Naturally, yes, they were extremely interested. They liked all of it. They liked the simplicity and speed. They said, you built something new in 3 years, got it flying, and how long did it take? Half a year? So overall, everything was cool, awesome, and they started throwing out ideas about where it could be used. The guys are looking forward to further development. They also mentioned that transport drones, like ones that can carry half a ton or a couple of tons between regions, are in high demand overall.
Interesting. I was also really interested in watching those first impressions from people who just arrive at the airfield, see all of this with their own eyes, watch it fly, pass by, and maneuver. Those are truly indescribable emotions.
Yeah, we wish everyone could experience them. So come visit us.
Yeah, and as the airship gets bigger, those emotions will only get stronger. So, how is our preparation for NOVA-02 going?
I'm over there, you know, trying to naturally slip in answers to Gleb Italian's questions on V-contact. He's been deduasing us, especially about the stratospheric probes that we supposedly abandoned. No, we haven't abandoned anything. Right now, we're carrying out a big program. The truth is it's impossible to film everything. The operator, if only a quarter, and it is unlikely that there will be quality content from each quarter.
Quartering.
Yeah, this summer we'll be launching more powerful devices. We'll try to film what's going on there over the next 2 weeks. There's a lot of interesting stuff happening. The onboard systems are developing, and we've designed a brand new shell, with a large one already being welded. And we've prepared a lot of ballast power shells as well, and we're working on perfecting the launch system. There's just a ton of really awesome stuff. Arkady is working on it in a semi-autonomous mode, under the careful supervision of Dmitry Khmel, of course.
Yeah, no operator with them. They haven't been able to film anything.
We took the operator with us out into the field. We'll reveal a bit about what's going on with the Stratosphere project, but it's all moving slowly. We tried to launch a round-the-world trip, and it's been a couple months. Yeah, and for the evolution of the technology, a couple of months really isn't much. Although with the pace we're moving at, it kind of feels like 2 years. We'll tell you about it and show you.
Either way, speaking of the stratosphere, we recently released a big documentary film. If you haven't seen it yet, you definitely should. It's a really interesting and informative video. I highly recommend it.
Yeah. Next, it says something about NOVA-02.
Yeah.
NOVA-02. While our younger team members were working on NOVA-01, our airship veterans, who, by the way, just wrapped up a work session, were busy with something else. The Academy of Aviation and Aeronautics Sciences was holding a meeting here. It just so happens that a large number of the Academy's members work with us, plus my people are nearby too. So, in short, they decided to hold a work session here. I'd be thrilled if this became a regular thing, with AERONOVA turning into a sort of hub for enthusiasts and experts. We're enthusiasts, not experts.
Agreed.
Yes, so basically, well, they were working on NOVA-02, of course. The first prototype was built really quickly, just thrown together, the nacelles and all. Today, in the workshop, They're finishing up the second prototype, which is also temporary. We're all trying to finalize the dimensions there at the moment. Things have settled, but details remain: angles, ceiling height, and seat space. While the team that is currently working on the cabin is carefully handling all those many little things, the structural framework has already been fully finalized, and all the necessary static and dynamic load calculations have been thoroughly done. The layout of the engine compartment is almost finished. Everything is coming together, from the engine mounting itself, the engine layout, attaching the gearboxes to the engine, the swivel transmission, and the swivel transmission itself. The duct fan engines, which are a crucial part of our project, have already been carefully designed, and now we've moved on to the next phase, which is actually building them. In addition to the prototype, it turns out that right now Ruslan has already started manufacturing the gearboxes for the swivel transmission, the housing, the gears, and so on. He started machining all of this because we've set up the lathe milling machine and, actually, the 5-axis milling machine. Everything is running like clockwork. The regions are set up. The engineers have started issuing the design documentation, so now we can start preparing the parts. So the work with the hardware is in full swing, and the cabin mock-up and further development are also underway.
And what about the rest of the airship? The envelope is being developed.
Right now, we're in the calculation phase, and it's really difficult to model soft materials, especially at the boundary between soft and hard materials, and even more so when there's friction, deformation, and so on. In general, the main envelope has been designed. Right now, the attachment points that have been developed are being calculated under various conditions, like a hard landing, for example, and so on. But overall, yes, the lion's share of the work on the envelope design is finished. As I mentioned earlier, we've already purchased the material for it. It's currently on its way to us, which is definitely good news. The equipment for welding this envelope has been selected. The equipment has already been paid for in advance. There's a cutting table, a cantilever high-frequency welding machine, and another one. I can't quite remember its exact type, a high-frequency welding machine as well. So, the equipment will arrive here in the summer, and welding of the large envelope will begin in the summer. Also, the engines that have been paid for NOVA-02 will arrive in the summer as well. That same summer, the engines will be mounted on the test stands, and everything will be equipped with the fuel system, the engine control system, and the swiveling transmission. I don't know if Ruslan will manage to finish the tilt-rotor engines by the end of the summer. We'll see. But by fall, everything will definitely be on the test stand, running and being fine-tuned.
So, for the most part, we're practically there.
The control systems for the NOVA-01 are already being tested, and some things are even being refined. Of course, there have been a few nuances that arose. For the most part, these issues will be related to the next airship, the NOVA-08. There won't be such problems with the NOVA-02, but these nuances have already come up and we're addressing them, even now, or rather, we've already fixed them. We found them. In short, when the electric motors are running, the reactive currents in the networks cause interference. And because of these voltage spikes, it's not the controllers that manage the motors that are affected, but the controllers that manage those controllers. One of them, on the stern thruster, kept constantly rebooting. It all happened quickly, but the computer recorded it. Naturally, we figured out why. We added electrolytic capacitors. So, everything is fine now. The control system for NOVA-02 is up and running.
So, work on NOVA-02 is underway, of course.
So, when are we going to fly the NOVA-01 again? As I understand it, we need to work on it now and catch up on the engine hours so that our program, our piloting system, everything gets better, improves.
We need more flight hours. So, Dima and the dedicated team of talented programmers are currently in the process of carefully writing the very algorithms that will ultimately control the airship. The plan, of course, is to finish writing them by the beginning of next week, and starting next week, to conduct actual flight tests in a kind of semi-automatic mode, where you set the parameters from a tablet, so to speak. Vadim Vasilyevich is now writing the flight test program, basically as a task. The task is, for example, to ascend to an altitude of 30 meters and, despite the wind, hover at a specific point, for instance, according to the GPS sensor. That's it. Dima enters this flight mission, presses start. The airship, of course, for now we're not keeping it at the lower mooring point, but in the future it should detach from the mooring point, fly to the coordinates, and carry out the flight mission. Next week, as planned, we plan to start working on things like this, if the software says, I'm ready, and, in all likelihood, that's how it will be. We need to make it do a figure 8 or similar.
Yeah, I'm curious. What kind of tasks will the airship have? What kind of flight tests and objectives will it face? Like making it fly on a figure 8?
Vadim Vasilyevich, when he writes, it will likely be shapes, squares, triangles. For example, 3 points. You need to fly to this one along a certain trajectory. Here you need to climb higher, then return. Things like that. And of course, all this needs to be done in different winds, in different weather conditions, to see how the airship responds. Like wind from the right, wind from the left, wind from below, wind from above. Well, that'll just be a matter of statistics, you know. We might be able to do part of the testing. For example, if we're lucky, there'll be calm, a north wind, some other kind of wind, but for a west wind we might have to wait, or maybe change the task. I don't know what it'll actually be like, but it's really just about building up statistics on completing flight tasks. Now Vadim will show us, and we'll get started. Pavel Agmatov asks, can you control the airship like an FPV drone? Yes. We're going to start testing that next week as well. In our office, we actually have a remote operator station with a full seat and a control panel. Yeah, the airship is equipped with cameras. I can't remember what they're called, but basically, they're industrial cameras with the right kind of lens, wide-angle ones. The cameras look in all directions, forward, backward, right, left, down, down in front, and down and back at the mooring lot. Basically, all this video is displayed in the correct format on 3 monitors, the ones you saw, the ones we set up for the simulator. There's also a seat there, where pilots used to fly in the simulators and learned how to fly. So this is the remote pilot station, and it turns out this is the pilot seat. There's a computer there, of course, and it's connected to the internet with a regular cable. And the airship is connected to the same internet, using 4G towers. It has 2 modems on board, one from MTS and one from Megaphone. So, with just a few milliseconds of delay, the operator will be able to receive the video feed. Obviously, there will be some indicators on his screen, altitude, speed, pressure, and so on. And it'll be controlled just like an FPV drone.
Yeah, the guys told me. They have high-precision machine vision cameras installed there.
Based on these same cameras, the algorithm itself will eventually learn to collect data, control the airship, and see what's happening around it while carrying out its flight mission. For example, if there's a tree in the way, or some object in the air, or anything else, it'll be able to avoid it, fly around it, and interact with it if it's a mooring point or something else, or a load that needs to be picked up. Using these same cameras, the computer will calculate wind speed by looking at the treetops during landing.
Really?
Well, yeah, it's the 21st century. Algorithms can do anything.
That's awesome. Are you planning to take the airship up to its maximum altitude or do any high-altitude flights?
Right now, we've filled it with enough helium so that the remaining volume inside the envelope, which will be displaced by the expanding helium as we ascend, will allow us to lift the airship up to 1 kilometer. So, once we complete all of Zukovich's flight missions, and maybe one of those missions will be to reach 1 kilometer, we'll see, then why not? Of course, it's possible and even necessary to take it higher.
Because we're honestly curious ourselves to see how high it can go.
Well, no. Theoretically it'll go up to 1 kilometer without any issues, but we do need to actually take it up to 1 kilometer. It would be interesting to see the view from under the airship up there.
By the way, will there be any issues with conducting all these flight tests with the new features?
No. All the procedures have been coordinated with the Airfield Administration, so there won't be any problems as long as we follow the procedures.
Protocol.
So, do we have any other news? News? Who knows? There's a lot going on. Are we going to register the NOVA-01 with Rosaviatsia? Our lawyers called Rosaviatsia, and they were told that the concept of an unmanned airship doesn't exist in Rosaviatsia, nor is there any requirement to register it. As they say, the way you name a ship is how it will sail. And if you call it an unmanned aerial vehicle, then of course it needs to be registered. While it's still experimental, there's not much point in registering it, but for future commercial use of its other modifications, of course, they will be registered.
I think we'll have to, yes. Because if you make the NOVA-02 or NOVA-08 unmanned, that doesn't mean you won't have to register it. That probably wouldn't fly here.
Listen, would be great.
It would be great, and we'd use that chance.
If only we could use a NOVA-08 in unmanned mode without having to register it.
All right, then I suggest we move on to questions, if we have any at this point.
The program is unmanned. Will it be integrated into the existing air navigation system? Most likely, in the near future, will be fully integrated into the existing air navigation system as part of the process using well-known integration methods. We'll install the necessary equipment on board and transmit the required commands on the designated frequencies. How will air traffic controllers interact with unmanned airships? For now, it's set up so that you can issue flight tasks via a laptop or tablet. Basically, you can do it from home, out in the field, at work, it doesn't matter. It will also be possible to take over control remotely from the same tablet or computer. However, we haven't worked on that control system just yet. Most likely, it'll look like something from a video game. If it's a laptop, you will use arrow keys and letters. If it's a tablet, similar arrow buttons will probably appear on the screen. Yeah, but for now, the plan is to, at this stage, take over control specifically from a remote pilot station. That will be created more quickly, so to speak.
Okay, I have a question too. At this stage, does AERONOVA plan to establish any contacts or partnerships with companies around the world that are already developing airships and may perhaps be ahead of them in certain areas?
Yes, of course, that's the plan. First of all, the world of airship developers is pretty small and tight-knit, and everyone already knows each other. Right now, at this moment, even if we're behind someone, we'll catch up to them quickly and naturally proceed to continue to work with them moving forward.
There's another question. Will operators of fixed-wing UAVs who are used to a different interface be able to immediately operate the NOVA-01, or will retraining be required?
Look, once the algorithms are fully up and running, remote operators as such won't really be needed at all. Well, to be more precise, there will still be some need for them in certain circumstances. Naturally, operating them won't be difficult. They'll just need to go through a relatively brief and straightforward adaptation period. Because the pilot's seat we're creating now is more like a helicopter pilot's seat. It has basically the same controls, so, in a way, it's easier to be a helicopter pilot than an airplane pilot, relatively speaking. But based on experience, Dima Orlov, for example, flew a dirigible for the very first time, and he was able to fly it easily from day one. The only thing is, he was acting intuitively, doing what needed to be done, but you still have to know the procedures and take a course. A dirigible doesn't really fight the wind. If we were flying some kind of shell-less drone, like a fixed-wing copter or a helicopter, and the wind started to turn us, we'd use the propellers to push back, in order to effectively resist the wind. You can't make that kind of maneuver in a dirigible. There's no point in fighting the wind. You have to use the wind to your advantage. The way you control it is actually more like sailing, but you still instinctively try to turn the dirigible the other way, because you didn't want it to turn like that, but the wind just turns you around. You start trying to fight the wind, but that's not quite right here. So, you really need to learn that theory. Overall, the controls are so simple that you can get the hang of it in just 5 minutes.
By the way, Dmitri, did you have any previous piloting experience?
No. Dmitri flew drones, the quadcopter type, and he built them and wrote software for their autonomous flight. And overall, I don't see much point in having a human operator now. Computers will control everything soon. I agree with him. But still, for example, you still need a pilot if you're carrying people, so the controls are still being made for that.
Alright, okay, all sea shipments are insured, but is insurance required for cargo transport by airship? If so, which company do you plan to work with?
Well, it's definitely required. It's just like...
Matters.
Well, just like any air cargo company, there are certain rules, and there's a standard set of insurers that work in aviation. We'll go with the best ones, as always.
If necessary, yes, we'll choose from the available options. So, will AERONOVA be able to adapt a different control system with a different interface to the unmanned airship if a customer requests it?
If the customer gives a clear, workable system, we can. We built the airship from scratch, what can't we do? Today, when I was showing our guests from South Africa around the office, I took them to the lab where Dennis was sitting and soldering microchips himself. He was basically making printed circuit boards there. They were like, "What's this? Are you making microchips here?" I said, "Yes, the control system was developed from scratch, and we need a lot of custom-made circuits. We know every screw, every bolt, how everything works, so I think there won't be any problems adapting something from the outside."
Yes, in our last webinar we touched on the topic of detecting helium leaks in the shell, and in connection with that, here's the question: which method or methods did you decide to use and why? In the Telegram group, several solutions were suggested, such as a thermal imager, the Joule-Thomson effect, the Schlieren method, and acoustic emission. We decided on one.
Well, regarding acoustic emission, people often consider it a highly effective method in the field, especially as a diagnostic tool. As for the thermal imager, to be completely honest, I didn't quite understand how that could be done. I haven't actually asked the rest of the guys yet if they really understood, because with the airship, well, obviously, there's a jet stream coming out, there's a noticeable drop in the local temperature, and you'd need some kind of sensor arrays for that volume to be able to see all of it, to be honest. I like the idea with the frame, that when bringing the airship in and out of the hangar, some kind of frame is created, and you could have, for example, ultrasonic leak detectors there, or those same thermal imagers, or maybe both, or even some third type of sensors, such as other advanced types. The solution itself might seem trivial, simple, even obvious, that the airship, when entering the hangar, just needs to pass through a scanning frame, not after it's already inside the hangar, where you'd have to lower some kind of net with sensors onto it, or have drones flying around it, sniffing it out, but rather just a frame, yes, simply equipped with a set of methods. So, this isn't really a question for this year or even the next, which means we'll definitely find that simple, brilliant, and effective solution.
For now, our airship isn't that big, and we're managing with human effort and handheld sensors.
Yeah, so RDM basically took two highly sensitive scientific devices that detect helium in the air and meticulously record its concentration. He mounted them together on a single frame, attached 2 nostrils, so to speak, on tubes, and walked around sniffing the airship, checking all the seams. He did all this in just a couple of hours, meaning with a small airship, after a few hours, we were already confident that the seams weren't leaking. The areas with nose-to-tail reinforcement, where some beams go into pockets, where some flanges rotate, those weren't leaking either. We found just one single leak. It was, in fact, specifically and ultimately through the flight termination device that it happened. There's a membrane there, with a tungsten wire soldered between it. Basically, this wire comes out of the membrane and goes into the housing, where the electronics ignite the membrane by radio signal. And right where the tungsten enters the housing, that's where a little bit of leakage was coming from, but it wasn't a big deal. When recalculated in liters, it was just a fraction of a % of the total leaks from the entire shell.
All right.
By the way, we measured the total leaks from all the shells, and they turned out to be, basically, during testing, each material has a certain number of liters that leak per square meter. So, in total, I don't remember exactly, but it was about 150 square meters, give or take. With 2 liters per square meter, there should have been 315 liters leaking from the entire airship per day. That's 0.3 cubic meters. So, basically, that's just one tank, and that's it. You wouldn't even notice it. Well, it loses about 300 grams per day, which is kind of an expected loss. But look, those were the characteristics of the material itself, not taking into account the welded seams and all the other things like the inserted filling valves and so on and so forth. So, we end up with about half a cubic meter of leakage, roughly 0.5 to 0.6 per day. I think, in fact, taking into account that venting rupture device for flight termination, all the welded seams, and so on. So overall, there are absolutely no leaks on the airship itself. All the helium losses are entirely in line with the preliminary calculations. The only thing I want to remind you is that we made this airship from the materials that were available in our country, and they are far from perfect. And from the material that's currently on its way now, we'll also make a small airship, and it won't leak nearly as much, almost not at all, honestly. So overall, the leak detection method we have right now is, for the most part, enough to figure things out within a couple of hours. Also, in general, you can usually tell by the amount of lift, because even when the airship is in the hangar, it tries to take off, and you can use a dynamometer to see how much force it's using to do that. And if that force drops from day to day, it means you have about that much leakage.
All right. So, here's a question. By the way, maybe this was just a waste of money and time, and we should have just built NOVA-02 right away?
Well, first of all, we are already building NOVA-02 right away. Second, to build NOVA-02, we first need to set up the shell manufacturing, which we'll do this summer, and also work out the control system. And third, I've already answered this question.
Yes, because the cost of a mistake on NOVA-02 would be much more catastrophic than what we might face now with a NOVA-01 airship. And that's exactly why this innovative airship was specifically made to help prevent these kinds of unforeseen situations from ever happening, especially on a much larger model. Alright, next question. Will you be making scaled-down versions of NOVA-08 and NOVA-35?
I don't think so.
There's no need for that because what we needed was...
I would even say that it's practically impossible to make, for example, a true replica of NOVA-08 or NOVA-35, because the onboard power distribution system is already set up and integrated there. There's a dedicated generator, and there are already up to dozens of main propellers carefully arranged along the entire length of the airship's hull. So, to put it simply, it's already basically impossible to truly replicate their power capacity, thrust, proportional drag, and so on. But at least it's good that we managed to build this one. With its control system moving forward, adapting will be much easier. So no, we don't plan to build small airships as training models, but we do plan to develop, or rather, not redevelop, but create small airships for advertising and observation purposes, specifically for those particular uses. Shell production line, mass production starts now.
By the way, here's a question about that. Will they have the same shape, or will they be different?
This is considered the optimal shape for the envelope itself, and, in all probability, it is also regarded as the optimal shape for the tail assembly as well. But the placement of the engines, their power, the number of them, the shape of the frame, well, the so-called gondola, that's all going to change, right? Everything else will be different.
So, will it be possible to make the NOVA-01 using new materials for the envelope in a different color? For example, I want a red airship. Will there be tests with other colors? And in general, airships in other colors?
Yes, you can do anything you want. You can make it metallic, you can even make it black if you want. The only thing is, that will really affect how much it heats up. A black airship, for example, will also cool down very quickly. There are always nuances, but of course, at the customer's specific request, absolutely anything can be accomplished if needed. The only thing is, there will be warnings issued, for example, that it's white not because of some tradition, but specifically because titanium or aluminum oxide of that color, in this context, reflects ultraviolet rays well and protects the envelope from premature degradation. You can also metallize it just as effectively, for example, to reflect those same solar rays, but then you run into problems with welding the envelope. You can't weld the envelope this way, place it side by side and lay a strip behind. The metallized layer can't be welded.
Increase its weight?
No, it doesn't increase weight or affect strength in any way. It just makes manufacturing the envelope more labor-intensive. It's doable.
Another question.
Will we? God only knows. Here in Russia, there's an intention to start producing shells with a gold coating, and that intention hasn't gone anywhere. Ever since those first agreements, I would love to see golden airships over Moscow.
It does sound, of course, yes, very promising. So, we haven't flown along the river or over the lake yet. That was another question here, so not yet. Have you already tested docking in strong gusts of wind? How is that generally going to be done? Will you wait for strong winds, or is there some kind of simulation available?
Performing an automatic docking maneuver to a tall mast, even when there are strong and unpredictable gusts of wind, requires precise control and advanced technology to ensure a safe and successful connection. I think we'll solve this task within this year without the team's involvement. Overall, there's nothing complicated about it, and automation these days, I mean, you've seen it, robots are running around.
Through the forest, over rocks, over logs.
Yes, I think the automation system will, without much difficulty, easily replace the crew that used to handle and dock huge airships on the rooftops of tall buildings, especially in windy conditions and so on. For example, these systems are designed to adapt to such challenges. We'll figure it out.
And people ask if a device sensitive to wind, rain, snow, and frost is practical in Russia.
With a certain scale, all this sensitivity
decreases.
Yes. For example, right now, when we take a small device out into the field, it's like going out to sea in a tiny one-person canoe. Every wave is a big deal for us, especially near shore. Near the shore, it's just like how the air fluctuates near the ground. It's deadly. It can flip your kayak over, and that's it. But if you're on a cruise ship or a cargo vessel, even a storm is hardly an obstacle for you, after all. Of course, if it's something truly extreme, everyone avoids it, even with those kinds of vessels. So, as the size increases, weather conditions have less and less of an impact. Snow, rain, frost, it doesn't matter. You just design the vessel knowing what it's going to face, and that's it. Alright, is there any plan to test the emergency release system, not for air, but for gel, in conditions with increased interference or jamming? For example, at least by launching it in a stratospheric balloon and checking the communication. This is probably about the flight termination device. Yes, that would be a pretty expensive test with helium and all. We actually tested it here in the city, in Moscow. Everyone knows there's all kinds of noise and jamming here. We had the device sitting in the lab, and someone would walk a couple of blocks away, press the button, and even through all those walls, windows, Wi-Fi interference, and everything, it still worked just fine. Do we just need to burn it through for fun, so the airship comes down and loses its gas? Well, sure, you can do that if you need to depressurize it. We'll do it. So, if the airship is unmanned, then why not fill it with hydrogen? Good question. Why not? I agree, but probably not right away. At first, we'll stick with safe helium. In the future, maybe, why not, once we figure out how to handle it better and keep the whole team safe, because before you send it on a flight, you have to assemble it, inflate it, and move it around, standing in the hangar next to all that hydrogen. Yeah, and you really don't want to be crossing your fingers either. Okay, we've already covered that question. When the airship reaches the end of its service life, will it be possible to reuse the helium? After all, that's a huge amount of it. Yes, but helium gets dirty, it gets contaminated, clogged up, and so on, because of gas diffusion and all that. Contaminated. There is such a concept as partial pressure. It's when you have a boundary where, on one side, there are a lot of molecules of certain substances, and on the other side, there are few, and the molecules still tend to move over there. And so, air molecules still enter the shell. The same kind of molecules can easily be released from the material of the shell itself, or from the material of the valves. So, in any case, things get mixed together over time. And helium gets contaminated pretty quickly, it gets dirty, and actually, it even needs to be purified. The Germans have separate units for this, which buzz nearby in the hangars, pumping the gas through themselves. We're developing an onboard purification system, of course. Yeah, we don't plan to lose any helium. Ideally, it should be cleaned and reused many times.
Wonderful. All right. Well, this question was to be expected too. Have we already found a hangar for producing the NOVA-02? Do we have anything in mind?
No.
Hangar we have won't fit NOVA-02, right? No. The NOVA-02 is about 44 meters long, if I'm not mistaken.
And even this one barely fit in here. Yeah, the 17-meter one. A hangar was selected, a pneumatic frame boathouse for purchase and deployment on the territory, for example, at the same airfield in Novinky. For instance, we could set it up there right now.
Temp.
Yes, everything is temporary, and then you can move it somewhere else, or set it up at the airfield we originally planned to buy, but that didn't work out because it was sold under previous agreements.
In Novinky, that's possible, since the land there is available both for rent and for purchase.
Yes, and in general, our acquaintances have that land, and as for a temporary structure, why not? It's just a matter of how to set it up. And regarding any large, existing hangars, well, for NOVA-02 we planned for it to fit into a standard hangar, the kind that can accommodate Boeing 700s or something like that. No, we haven't reached any agreements with anyone yet, mainly because this won't happen anytime soon, so there's no point in bothering people in advance. And still, we're probably counting on installing a pneumatic frame. Because we have to occupy a hangar, and for a long time, for example. That's just overhead costs that go nowhere. And buying our own, even if temporary, still sounds more reasonable.
Yeah, and it's nicer. So, which airship can you land on water, and is that feature even planned at all?
Well, actually, you can land any airship on water.
Pret.
Right. People ask, will it be able to take off again afterward? Yes, it will. Yes, the Nova-02 can land on water, but there's really no point in doing that. Now, the Nova-08 can easily be made to land on water. And of course, all subsequent airships should be able to land on water as well.
All right, well, I think that's all the questions. I hope I covered everything you wrote. If I missed anything, I apologize. So, it seems like we've gone through everything we had. I think it's time to start wrapping up, unless there are any more questions. Let me take a final moment to carefully check once again to ensure that there are truly no additional questions from anyone in the audience. Yes, it appears that we have addressed all the questions that have been submitted, and there are no further inquiries at this time. With that, we would like to sincerely thank each and every one of you. We hope you found it interesting and informative. Be sure to join us for future sessions and keep following us.
Yes, we'll try to shorten the delay between real events and when the news comes out on Telegram, at least if not on the other social networks. Next week, we're heading out to the airfield. There will probably be a lot of interesting things happening, so stay tuned.
Yes, see you soon. Bye everyone.
Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.